All right, good morning, everyone. So, if you're at home today, if you're a part of cohort 2, this is the video that you'll be watching. I apologize if there's a little bit of echo in the audio here. I moved my computer desk at home, and of course, now I'm in a less great space for audio, but hopefully, it's not too bad. So, what we're going to talk about today is something called the Z-score. Now, I know I mentioned this a little bit at the end of class yesterday about the Z table that's on Google Classroom. So today, what we're going to do is just get a little bit more into what is the Z-score, how do I calculate it, and what does it mean, right? Now, first things first, the definition of a Z-score is pretty straightforward and pretty easy. All it is, it's a number that tells you how many standard deviations a data point is from the mean. That's all it is. So those numbers that you see, and I know that we talked about this a little bit, it's a negative 2.7 means it's 2.7 standard deviations below the mean. So another important thing, right? If it's negative, that means your data point is below the mean. If it's positive, obviously, that means we're above the mean. So all of those things are very, very important in terms of helping you to interpret what your Z-score is and what it means. Because typically the types of questions that you'll be asked will ask you to calculate and interpret in context. So it's important to understand if our Z-score is negative, that means my data point falls below the mean. If my data point is, or my Z-score is positive, that means my data point is above the mean. Now, the next very important thing that we get to is what is the actual formula? And it's just about as straightforward as it sounds. So your formula here, we'll do this in pink, is Z equals, now as silly as this sounds, x minus mu over sigma. Now, a couple of things that are important here. Number one, we'll use red. Sigma, this is obviously your standard deviation. Mu, this is your mean of whatever your distribution is. And x, this is your data point. Right? So, that's all it is. Literally, take the data point, subtract the mean, divide by the standard deviation. Seems pretty straightforward. Now, another thing that's important, when you look at the table that's on Google Classroom here, all of these percentages that you see here represent the probability less than the Z-score, right? So the Z-score table, as you can see from this picture here, right, is always less than or equal to. Always, 100% of the time. So you're always going to look at what is to the left of your given data point. So it's important to understand, if we go back to our notes here, right, the Z table tells you the probability, probability that something is less than your data point. Right, so this is important because depending on the type of question that you are asked, you will then have to, if they're asking you what is the probability that something is greater than, we're going to have to do some math. So I think the best way to actually talk about this is to look at an example. So let's say I have a distribution where the mean is 100 and the standard deviation is 50, right? And so I want to calculate what is the probability that a data point is less than 125. So a couple of things, right? Basically 125 or less. So a couple of things that are important here. One, if I see something like this, I automatically think that's a Z-score. What's the probability? Because remember, the normal curve is a probability function, right? Probability that something is less than 125, I automatically think z-score. Now all I do is plug into my formula. Value minus mean, all divided by standard deviation, right? Most of us, we're pretty smart here. There's not a whole lot of math to do here. But just to show it for the sake of the whole calculation, I get a z-score of 1/2. Important. This number here, this is your z-score. Not your probability. Right? That's a z-score of 0.5, not a probability of 0.5. That's one big place where people will make mistakes, or where you'll see in multiple choice questions, instead of listing the probability, right, they'll also have the z-score as an answer choice, so people make that mistake. This is your z-score, right, not the actual probability, right? So that's my step 1. Compute your z-score. Step 2, I'm going to go look at my table. Right? So now that I've found my z-score of 1/2, I'm going to go look at the table. Right? The first page of your table is all negatives, as you can see here. This isn't super great. Second page, now I find 0.5, right? So I'm going to zoom in here on 0.5. And 0.5, and I look in the first row, because that's going to give you your hundredths place. Well, 0.50 is just going to be this 0.6915. I wish I could highlight it, but this number right here in the middle of your screen. And remember that that represents the probability, right? The probability that I have a data point less than 125 equals, 0.6915. I'm done. That is the easiest way to compute a z-score. That is the easiest type of problem where you're going to be asked, what if it's less than this given data point, right? It's always going to be the same 2 steps. Compute your z-score, then go ahead and look at the table. The difference is going to be, what are you going to do with the number from the table? So if you have questions at this point, please write them down on a piece of paper, and I'll ask you to also submit that piece of paper to me at the end. So what I want to look at now is there's 2 other cases where you may be asked to use a z-score to compute something, and we'll talk about how to do that, right? So let's take the same data set, right? Let's say I have so we'll call this case 2, right? Let's say I have the mean of my distribution is, we'll still say 100. Let's say the standard deviation is still 50. But instead now, I want to know the probability that x is greater than 152, let's say, right? So again, I compute my z-score, 152 minus 100 over 50, right? Which is 52 over 50, which I believe, if I do my math right, is 1.04. Right, 26 over 25, sounds about right. Now, the difference here, right, I still see this, I still know this is my z-score. The problem is, though, remember, the table, right, for my step 1 of computing my z-score, my step 2, though, of looking at the table. When I go look at the table, I find 1 here, 1.04 puts me over here in this column in the center. I zoom in on this 0.8508, right? So I know the probability, remember from the table, that x is less than 152 equals 0.8508. So in order to figure out the probability that x is greater than 152, all I do is 1 minus, right? So the probability that x is greater than 152 is 1 minus the probability that x is, of course my stylus is freaking out, there we go, less than 152. Now remember that the 1 comes from, that is the entire area under your normal curve. Because it's a probability function, when I sum everything up, it has to be equal to 1. So now it's as easy as 1 minus 0.8508, which should give me 0.1492. So when you see something where you're being asked to compute the probability of x being greater than something, we still find the z-score for that data point, but now instead of doing a normal just give me the number from the table, now it's a 1 minus the number from the table. So that's the second case where you might be asked. Now there is a third, and I'm assuming, right, we probably have a good idea of what it's going to be, but, right, we're going to take the same distribution for case 3. Our mean is 100, our standard deviation is 50, and this time, let's say I want to know the probability that x is between 75 is less than x is less than, let's say, 130. I want to know the probability, whoops, I forgot to put the less than sign, less than 130. I want to know the probability that x is between two values. Now again, if I see a normal curve and I see a probability statement, I automatically know the z-score. The thing is now, though, I have to compute two z-scores. So I'll find the one for 130 first. And I'm not going to show all the math out, but we should know that that's 0.6, right? Just ends up being 3 over 5. And I'm also going to compute the z-score for 75, which should give me negative 1/2. Or if I keep this consistent and I do this all as fractions, negative 0.5. Now remember, on a bell curve, so if I draw my bell curve here, on a bell curve, the z-score table always gives us the area underneath. So if I have, actually let's use black here, here's my mean, right? So here, let's say roughly, is 130. So on the z-score table, I get all of this when looking at 130. Right now, if I pick a different color here, let's pick bright blue, right? Here, let's say, right here, is 75. So when I look at the z-score table, I get all of this from 75. So in order to figure out what's between them, all I have to do is subtract out the area to the left of 75 from the area to the left of 130. Meaning all I have to do here is get rid of all of this just by subtracting what's less than 75, right? So now what I'm going to do for my step 2 again, of look at the table, now I'm just going to look for two things, right? So when I go less than 0.6, I get the 0.7257. So the probability that x is less than 130. And my stylus doesn't want to write. And there we go. Still doesn't want to write. Maybe we got it. There we go. We're just going to make it work. Is, what was it, 0.7257? Yep. And the probability that x is less than 75, now when I go look that up, I have to go to the first page, because it's negative 1/2 is going to be that 0.3085. So now all I have to do is subtract these two numbers. That's it. A big place where people make mistakes is they subtract the z-scores. Remember, subtract your probabilities. Don't subtract your z-scores. There's supposed to be an I. Probability. There's an I in there, right? So the biggest place where people make mistakes is they'll subtract the z-scores, get your probabilities first, and then subtract. So when I do that subtraction, what do I end up with? So let's see, let's actually do some subtraction now because I don't have Wait, I didn't have to do that. What am I doing? 7 minus 5 is 2. Then I got to take 1 here. That's 7. 1.4172. Sounds about right. So, just a quick recap. We've covered all 3 cases of a z-score. Easiest case being, what is the probability that x is less than or equal to something? Boom, that's read straight off the table. Second case being, what's the probability that x is greater than something, that your value is greater than a certain number? Well, then I do basically the same thing, but once I find the value from the table, instead of just taking it, I do 1 minus, so that way I get the other side of the curve. And lastly, what if I'm stuck between 2 values? Big key here, get the z-score for both, get the probability for both, and then subtract the probabilities, not the z-scores. So if you guys have any questions, please feel free to submit those to me. I hope you have a wonderful day and a great weekend, and I will see you guys next week. Bye, guys.